Good afternoon, everyone. Thanks for joining in again. Welcome, everybody. Welcome, Daniela, Eddie, Boy, Paul, Robert, Steven, Timothy. I'm here to see some people like Femi. I'm here to see some other people that I know their names. I can't really remember all of their names now. I know Femi, Samuel. They are here to join the class. Hopefully, they join us along the line. Thank you guys for joining again. Today is the 7th of our AIML for Developers Bootcamp. And I want to actually say a very big well done to everybody that has been joining since day one. I know this is a free bootcamp, but seriously, you guys actually took the time upon yourself to actually be here. It's something, right? So yeah, this is day 7. And also I want to say thank you to Mr. Nehemiah for actually being here since day one. Welcome, and thanks for joining. I can see you. Right. So yeah, so that we don't take too much time, I would give the mic to Mr. Nehemiah to commence. At the end of the class, I would make some few announcements. I mean, we can go over what one dev is, especially for those that did not join us from the beginning of the boot camp. We can go over what one dev is, and I can actually we can actually talk about one dev again and what one dev offers everyone. Yeah, so Mr. Nehemiah, please, you can take over. Hi, Mr. Nehemiah, are you there? Okay, I shall mute you. Oh, sure, sorry. You can unmute now.
All right, thank you so much, and good afternoon to you and everyone. I hope you are doing well. So guys, today is yet another day to learn something on Python as we try to wind down on Python. And right away, let me share my screen. First of all, can you confirm if my audio is clear? And I'm sharing the screen. Also confirm if you're able to see the screen.
We can hear you loud and clear, and your screen is coming up. Yeah, I can see your screen now.
All right. Thank you so much. Thank you so much. So guys, I want us to finish the Python so that we can discuss other things as well. So yeah, so last time we talked about, just to remind those who are joining perhaps for the first time. So we introduced Python as the core technology in the machine learning and artificial intelligence. And I just said on day one that if you want to learn a technology, it's not like to understand each and every aspect in that programming language. You need to just have that roadmap. You need to just have that, roadmap so that you can master that particular language. And the key thing on all languages, if you want to master, is first of all understand how to work with the variables, how variables are declared or are defined. And then once you done that, then you need to also understand how to deal with data structures because you have some data or maybe data types that allow, for example, the duplicates, they are unchangeable. We talked about those things when we introduced list, tuples, sets in the dictionary. So understanding those concepts is very key. You'll be able to understand how to deal with such data structures. And then also another thing you need to understand on a language is the functions. To understand how to group things, because you notice that, for example, if you are writing your code without the functions, and the Python usually execute code line by line. So like if you have like a lot of code, then it means that it's going to like, for example, if you want to execute like at the very last program, so Python is going to like execute everything from the very top and then it reaches the other end. And the thing in development is to make sure that you're optimizing, like utilizing like a few resources and also, including the time and the spaces. So we came to realize that Python function could be very, very useful because these ones cannot be like, you cannot like run it the way unless you call it. It's not going to execute unless you run it. And then also if it is an object-oriented programming like Python, in Python, almost everything is like an object. So to understand like how classes and objects are created and the methods That's also a very, very key thing to understand. So once you understand the variables, the structures, functions, classes and objects, and sometimes the modules, and then you are good to go on that programming language. So other things you'll be able to understand is you try to do something like try to solve a particular problem. Then you'll do some research and find out that there's some methods problem to solve a particular, problem that you're trying to tackle. So now today I want us to, before I talk about the classes and object, actually we talked about the variables, we talked about the data structures, we talked about the functions the other time. And then today I want us to talk about the classes and objects. But then before I go there, I want to talk about something briefly about the algorithms and the big O notation. So first of all, consider an algorithm as a set of instructions to do a particular task. Like for example, let's say you want to print, for example, 1 plus 1, 1 plus 1. So this set of instruction that you're using, for example, to get the summation of 1 and 1, this now like your algorithm, like just a set of instruction that you're giving a computer to do a particular task. Like that set of instruction is what we call the algorithms. So a set of instruction that I usually use to solve a particular problem, that is an algorithm. And we've learned many things, and we noticed that there are several ways on how you could solve a particular problems. Like there are many set of instructions that you could use to solve a particular problem. So, for example, to get this output of 1 plus 1, you could write it directly on the print statement, or maybe return, okay, print statement. Another way is to use, for example, the variables, and then I pass here the variable names instead of the values directly. Or maybe another way is to use what is to use to use maybe a function. You can create a function that is going to like calculate 1 plus 1, then you get the results too. So like all these methods are going to be used to solve a particular problem. But then now it reaches a point, it's not about just solving the problem, or maybe just, accomplishing a task, or maybe writing a set of instruction to solve a particular problem. Now you want to consider other things like, because we saw that there are several ways on how you can solve a particular problem. So what you're trying to do is now to understand the effective or maybe the efficient way that you could use to solve a particular problem. Like you're going to consider the resources like the memory that's going to utilize before it solve a particular problem, and also the time that's going to take to solve a particular problem, especially when the input says number of the input increases. So now this one takes us to a very important concept to learn called the big O notation. Before we talk about the class, I want us to talk about what the big O notation briefly. Big O notation. So basically, the big O notation is just a mathematical way. It's not something like a concept to learn, but then it's just a mathematical way to describe the performance of an algorithm. Remember, performance. I mean the time and also the space like the resources that's going to utilize. So in once again, it's like the mathematical way to describe how the performance of an algorithm grows as the input get larger. Like initially, for example, let's say you had a list. First of all, let me run this one. For example, let's assume you have a list, and I don't want to rewrite everything. Again, I want to use just the list that we were using the other time. So let me find a long list here. Okay, here it is. So we have this list, and we have this input. So at the moment when you just run, for example, if you wanted to access the very last, remember the big O notation is trying to like to address like in the event, for example, you have the basically the big O notation, like it's trying to help us understand the efficiency of our code in the worst case scenario. a worst case scenario in this case, for example, in this list, let's say assuming that I want to reach this last element, So we're talking about accessing like the very, like the worst scenario, or maybe the worst case of something. Let's say you have a list of a million, elements. So like we are trying to like understand how is your algorithm going to perform for example, you want to access the very last element in that list. Remember, the lists are ordered. So you want to access like at the very last index in your list. So in that case now, you're going to use now the big O notation to understand how you will achieve that. And I will say that big O notation is just some mathematical way on how you can describe your algorithm, or how your algorithm will perform is the size of the input gets larger. At the moment, we're just using like a few input, or maybe the few number of items. So for example, if I wanted to access the very last index in this case, you'll notice that it's going to be very, very easier, because I have, okay, let me 0, 1, 2, 3, 4, 5. Let me use index 5. So you can notice even there's no time that's going to be taken to reach there, or maybe to access the last index. But then a scenario where, for example, you are dealing with more than thousands of, perhaps hundreds of thousands or millions of records. So to access the very last element, then it's going to be a hassle. It's going to be a hassle. So you need to find a way that you will be able to access the very last element, but with very minimal resources. Resources, I mean the time and also the memory that is going to utilize before it achieves that. Now, in the big O notation, we have the first notation that I will usually use. Okay, the first notation in the big O notation, remember it's not like in that order, but then the one that I'm going to begin with here is, or the mathematical, way, just expression. The big O notation, the first one is the constant time. So basically for the constant time, here you're going to pass here 1. So this O, then into brackets, then 1. So this is what we call the constant time. So this one is irrespective of the size of the input. Like at the time and the resources that is going to utilize to achieve, or maybe to access that index. Okay, like trying to solve that problem is not going to change, even if the input increases or reduce, like the time is just constant. And in such a case, let's say, for example, you want to access this first list, and I want to use the function. Let me just use the function. Because we talked about the function, and for me, I always like working with function instead of these basic variables directly. Remember, it's just the same thing, but then I always find it easier to work with function. So let me just call it, for example, constant underscore time, and then in this case, let me have here my element. Let me just have, for example, list. Remember, you cannot use the list because there is an inbuilt keyword in Python. So let me use something like a lst, and then let's say it is a list, and then we want to access the first index. Remember, irrespective of the length of this list, to access this first index is not going to, even if you increase the number of the input, to access this first index is going to be constant. Even if you increase the number, but then you're only focusing on the first index, is the time is going to be just the same, because you're interested only with this first index. So let me demonstrate it this way, and I'm going to use the return statement. I explained the return statement the other time. So in this one, want to use this list, and then access the first index. So irrespective of the, okay, let me say here, I'm used to VS Code. So let me say array access. Array access is, let me use the big O notation then. So this is a constant time. This is a constant time. Let's have okay, let me have this list. We have created now the function. Okay, let's try it now to to call it. So we need to pass in what the arguments. We talked about the arguments the other time. The argument is now the information that you're passing to your function. So here I can say, for example, the constant. I can use this one, and then I'll be passing what inside as the values, the fruits. So now when I call, I'm going to access what these are first element. So irrespective of the number of the input, this one is not going to change. So basically there's some algorithm, there's some libraries that you could use, for example, to check the time taken. But then I just want to like display or maybe explain orally because there's no, there's libraries that you could use to measure the time that it has taken to execute, and also, for example, the resources. But then you can just note that to access this element is not going to change irrespective of the input because the first index. Let's say you have, in your basket, you want to access, for example, in your basket, you have fruits. And I want to pick like at the very top, fruit at the top on your basket. You can see the time that's going to take you to access it is going to just be constant, even if you only have one item in that basket, or you have like let's say 100 like a fruit in that basket. Because it's at the top, you're going to just access it like once. But then, for example, if you have like a number of fruits, let's say it is 100, but then you want to access the very last item or a fruit in that basket, then it means that you're going to remove, first of all, the ones at the top for you to be able to reach the other element, the other fruits. So you'll notice that the time is going to take you because to remove the other ones before your test, the very last one. So the time is different. Like for example, if you want to access the very last first element, it's irrespective of the input you have, it's going to be constant. Let me know if you guys you've understood the constant time, the big O notation before I go to the next one. You can say in the comment if you've understood. Are you guys able to hear me? Okay, all right, okay, thank you. I think so. That is for the constant time. Now we have another one called the time. Okay, we have another one called the logarithmic time. I think we have another one called the logarithmic time. Let me have it. So for this one, you have to do what you have to. Let me just type here. Logarithmic. Okay, logarithmic time. Logarithmic time. How is the spelling? Rhythmic. Sounds logarithmic time. What? I don't know. I don't know how to write this one. Logarithmic time. I don't know if that's the spelling, but I think you understand what I'm trying to say. Logarithmic time. Logarithmic time. Now, basically, this one. Okay, it is the syntax or maybe the mathematical expression. It is O and log a number. So basically for the logarithmic time, so on this one is trying to like at the time is going to increase logarithmically as the size of the input increases. And a good example is a binary search algorithm. A binary search algorithm. Let's we are going to use the same. We are going to use just the same. Okay, we should change it to down. We are going to use still the same. Okay, let me utilize another one. Okay, let me use another thing, another function, and in this function, basically, I'm going to use. Let's use a binary search here algorithm. Remember, algorithm is any solution that you're trying to, or maybe set of instruction that you're trying to utilize to solve a particular problem. So the set of instructions. So let's just create here a binary search algorithm. Binary search algorithm, and then these are search. Remember, on a binary search, you need to first of all have a sorted list. For example, if it's a list, you need to have it sorted to be in the order. For example, if it is numbers 1 to 100, you need to like sort it so that when you'll be doing the binary search, I'm going to explain how it works in a few. So let's have first of all sorted a list. And then we can have now the target. The target is now the element that I will be searching. So these are the two arguments that we are passing this algorithm. First of all, let's understand how the binary search works. Let me use a new cell. Now, let's say you have this list. Let's say you have the list of elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. So these are already sorted lists. So we've sorted this one in the ascending order. This list in ascending order. So basically what a binary search usually tries to do, because remember the key thing is like I want to access the worst case scenario. Let's say we want to access this item. Okay, let me increase to 11, 12, 13, 14. I just want to make it at least long, 14. So what the binary search usually does, for example, the linear search, we're going to talk about it. For example, if you wanted to access this element or maybe 14, then it means that you will have to go through 1, 2, 3. Remember the iteration, like you're trying to go through this element one by one, for you to be able to reach, for example, the very last element. But then now, what a binary search usually tries to do, for example, if you have this list, it usually first of all begin by dividing your data into half, like your input. Like in this case, this list trying to divide it into half. So in this case, we have 1, 2, 3. Okay, these are 14 elements. These are 14 elements. So perhaps let me try to add 15 so that it can be easier for me to explain. Or let me just use 14. 14 is just fine. So what is the half of 14? Okay, basically let's do it this way. Like we're trying to add, first of all, 1 plus 14, and then I will divide, like we're going to take like at the very, the smallest index, and then at the largest index, and then we add them together. So in this case, the smallest is 1, the largest is 14 because it's sorted. So what we will do, we'll try to like add 1 plus 14, then I divide by 2. And then this one is going to like give us the decimal. And I don't want it to be that way because it will be difficult for someone to understand. Let me just, for this case, increase to 15. Such that when you try to divide between, 15 plus 1, that is 16. Divide by the 2, you get 8, right? So in this, is it so? Are we guys together? All right. Yeah, the half of 14 is 7. And the half of 14 is 7, but then I've just added here 15 so that it can be easier for me to divide instead of having the decimal. Let it be just 8. So in this case, the smallest number is 1, the index, and then the largest is 15 on this sorted list. So we'll be taking like 1 plus 15, that's 16 divided by 2, we get 8. So 8 is the midpoint, right? 8 is the midpoint. Let me just add this here to show that it is. Remember, it's not how the list is defined, but then I've just added here so that I can explain this algorithm well. So this one, like just added this 2 pipe just to show the midpoint. So basically, what the binary search usually tries to do, first of all, is trying to like divide your data into half. First of all, let's assume that I want to get, for example, the value of perhaps 15 or 14. Let me say the target value that we are trying to search. Our target is 14. Our target is 14. So basically what it's going to do, like it's trying to, first of all, split it into a half. Then it's trying to compare between the target value and at the midpoint. So is the target value greater than the midpoint value in this case? Is it okay? Great. Yeah, it's not okay. I mean, this is the target value. We are trying to compare it with the midpoint value. So we are saying, is this target value greater than the midpoint value or smaller than equal to, all right. Yeah, greater than. I think that's the best answer. So greater than, it is greater than. So now your algorithm is going to skip this because it's greater than, then it means that it's going to focus on this other side. It's going to focus on this other side. So the time that it could have used to iterate this one to check, so it's going to like a skip it. It's going to skip, and then it's going to go to this other side. So the time that it could have taken to iterate 1 to 3, so it's going to be skipped so that it can focus on the rest, so that it doesn't have to iterate over everything. Now, after this, then you are trying to also to check from 8, like this was the midpoint. Now from 8, so this is now the first number. So you're trying to, first of all, trying to check also from first of all, the algorithm, what's going to do, first of all, it's trying to check if the search value is 8. Okay, it's the at the midpoint. If it's at the midpoint exactly, then that will be the output. So you can notice that it's going to like skip the time that it could have iterated the first one and at the other one, then it's going to just return the output. And if it was smaller than, then it's going to do it, it's going to like skip the greater than this part, then it's going to only focus on the less than side. But if it's greater than, it's going to skip this part, then it's going to focus on this other side. So again, it's going to split. Your smallest number in this case is going to be a 9, then a 15. So 9 plus 15, you get 9 plus 15. Sometimes I just ask it to show that we are together. Yeah, 24, thank you. Then 24 divided by 2. Yeah, 12. So our new half is going to be here at 12. So let me just add here. Let me add here now this pipe. Remember, it's not the how lists are defined, but then I'm just adding here so that I can explain. So now in this case, again, you are going to as well do the same thing, like we're trying to check. You're trying to check, for example, is the target value, in this case 14, is it at the midpoint value? Is it at the midpoint value? The target value in this case is 14. Is it at the midpoint value? No, yeah, thank you. Is it at the smaller than or a greater than? Less than or greater than? Yeah, greater than. So the algorithm is going to do that. It's going to skip this part it's going to skip this part, and then it's going to only focus on the second part. On the second part. And then now we have what we have 13 and 15. Okay, the smallest 13, and then this one is 15. So 13 plus 15, that is how many? Yeah, 28. So 28 divided by 2. 28 divided by 2, 14. Now, is your target value at the midpoint? In this case, okay, let me just add here. Is it at the midpoint? This half, okay, yeah, yes. So if we like the target is that, then it's going to skip, for example, to trade this one, and then at the other one, then it's going to return the value. For example, if it were greater, then it's going to go on the greater side. So I've just used like a very small data set to explain. But then in the event, for example, you're using like a big data, then you will understand the significance of the binary search. The binary search is going to be very, very useful because I notice you've skipped some elements to iterate over them. And when you skip it, then that is time you are trying to do it. That's the time you are trying to save. And also the resources. And then this case also you're trying to like skip the time that you could have iterated here, so it is saved. And also the resources that you could have used to iterate here, it is also saved. And then I just check the midpoint, and then in this case also you're going to save this one, and then you're going to just return the midpoint value. So this is how the binary search does. Like it's trying to like to split the binary search, like it's trying to like split the data into half. Then it's trying to check, for example, if the target is at the half or a greater than or smaller than, then it's go to wherever, for example, the target lies, until it reaches the solution. Now, guys, the other thing that I said, before you begin to solve a problem, before you need to solve or maybe to write the code, you need to first of all solve the problem in mind. So the coding should be always the last thing. For example, if you have a problem you want to solve, make sure that you have that wireframe. Or make sure that you have the solution solved before you write the code, because you'll have like a lot of issues. So for example, if you don't know what you're trying to do, then you're writing the code. So you need to first of all know the problem and figure out how you will solve it so that you'll know how you'll be able to solve that problem. So the coding thing should be the very last thing. You solve first of all the problem before you write the code. Now in this case, we know what we are trying to solve. So what we are going to do now is to implement. So let's have, okay, I don't know why I deleted that cell. Okay, let's have the left. We know that we usually divide it into left and the right, or a greater than or a less than. Let me use left and right because you can either have left or right. So let me just say left, then right. I'm just going to define variables in one line. So, now, the first thing that we usually do, I'm assuming that the list, let me use create here a new one. I don't know why I deleted. Let me just say sorted list. Okay, let me just say my list, list, then assign it to just some number because we are not sure that all the time your data will be sorted. So we need to first of all sort the algorithm. Okay, not the input, the data, because this one works on the sorted data so that it can know how it is going to split. And then whatever it is, this order, and then so let me just have some random number because I'm assuming that it's not always the case that your data will go at the data will be sorted. Sometimes you might have like the input which is not sorted. So basically what we'll do now in this case, so first of all, the left will initialize with 0. The first index is 0 on the left, like at the initial should be 0, the initial index. And then now the right element, it should be now this very last element in this case. So that element to access the last index, because that very last index, what we'll need to do, we can use the number of elements because we are not sure about the index because you can see the numbers are not indexed. So what we'll do, we can use the number of, we can use the len, which help us to get the number of elements. Okay, the number of elements in your object, in this case, a list. And then, so this one is going to like return a scalar value. Let me do this. For example, let's say you have, okay, let me just have this list here, the same list. So, and then for example, when I say print, then at the len of the list, LST, is going to just return here scalar value 12, like at the number of elements. Yeah, and the number of elements. Now remember, this is the number of elements, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know how I've counted it, but then like these are exactly number of elements, the number of elements. But then we know that in indexing begins from, in Python, indexing begins from where? Yeah, it begins from 0. So if it begins from 0, and in this case, the number of elements are 12, so you can just guess that the number of the last index, because it begins from 0, is going to be -1, right? Because the number of 12, the number of elements in this case is 12, the number of elements, but then we know that indexing begins from 0. So our guess, not our guess actually, we can just know that the last element in this list is going to be the number of elements, the number of elements returned -1, right? Is it so? Yeah, great. So now once we've understood that, then the very last index will say what we'll be using now, the so in this case, actually, we're using this sorted list. The sorted list now -1, so that we can get the very last index. Because we need to first of all have the initial index and then the very last index. So in this case, we have done what? Remember, this is the same thing as having, for example, a variable left, then another variable right, then we assign, for example, left. Okay, I think let me try to simplify so that you guys will understand what it is. So it's the same thing as having 0 here, and then right, you give it this value. So it's the same thing, like, but then I was trying to just use it in the same line, the same line, but then let's just try to simplify things. Now, those are the Those are my initial variables for the greater than or the smaller than values. Now we can use what? We can use our while loop or maybe for loop. Let me use the while loop, I think, because this one is conditionally. Instead of having another conditional statement, we can just do it. We can just have the while loop so that it's going to cover everything. So we can say while left, while left is greater than or equals to right, while left is less than or equals to right, then we need to find what the midpoint. We need to find the midpoint. In the event, for example, the left, like in the event, for example, left is less than or maybe equals to right, then we need to do what? We need to find what? We need to find the midpoint. Because you notice that sometimes we might have the midpoint, like at the target value is exactly at what? At the midpoint value. At the midpoint value. So in this case, we can now define now the mid. So the midpoint value in this case is going to be in the event, for example, it's just normally like a left and right, the midpoint value. For example, the midpoint, remember I said that we need to split into two, like into two halves. So you're going to take the very first index, like in this case, if you had sorted, and then you're going to take the first element at the index 0, then the last index, then you're going to add them together, then I do what? And then I get the average. So sometimes it could be at that the same equal, like the midpoint, like the number could be point. I saw earlier, for example, if that cell, I think that cell, it was very significant. It was very important where we were getting like a number that will have the decimal. So that case we are trying to use, for example, either less than or equal to. So for example, if it's less than or equal to, then we can have the left, left, then plus right, left plus right, and then here we'll do what? We will now use a floor division so that you can round down to the smallest whole number. So we're dividing now, divide by 2. Remember, left and right, they are 2, so we are using the average, which is 2 now, to get now, so that we can get now the floor division to get it like at the nearest whole number, and the nearest whole number, so that we will not work with the decimal in that case. Now, the other thing that we will need to implement or do is now to get now the midpoint. Like I want to identify, because the key thing here, we're going to implement well the target, like we are going to specify the target value. So we need to find, for example, sometimes the target value could exactly be at the midpoint. You saw earlier when we were using 14, when we divided somewhere, it was exactly at, I don't know if it was 12 or 14. So sometimes the target value could be exactly at the midpoint where you're trying to search. So in that case, we can say, for example, if sorted list, of which the list that I will be using, the value that I will be passing in the argument, if sorted list, and then a midpoint value, which is this case. Remember, this one is trying to do it. This one is trying to like get the smallest index, of which we have specified the indices here, the initial indices, and at the maximum, the largest. And then we're trying to add those values together here with the floor division, and then we're doing the floor division to get the midpoint value. And then now we're trying to get, because of the essence here, we want to get the midpoint value. So for example, if the midpoint value is exactly target. Remember, when you use the 2 equal operator, it means that you're equating now. If it's equal to the target, of which you are going to specify the target in a few, if it's equals to target, then we will do what? We will return now the mid is our target. So in the event, for example, the searched item is at the midpoint exactly. Then so we are going to return now the midpoint. Now we need to implement to have an elif. Elif, for example, if the sorted list, sorted list, the midpoint value now, because first of all, we have, for example, assuming that at the case in the event, for example, the element is not is less than, not exactly at the midpoint, perhaps it's less than this side. For example, if you split it into half, then it's at the less than side. Then what we are going to do here is like we will do what we'll now specify here the midpoint first, midpoint value. So in the event, for example, the sorted list is at where? Is at less than. Okay, the like in the event, for example, the midpoint value is less than the target. It's less than the target, which means that the target should be greater than, right? The target should be greater than. If the midpoint value is less than, then it means that the target is greater than. So in that case, basically, we'll have to do what we will have to update now the left, right? We'll need to update now the left because the index, it will have changed. Let me see if I can redo it quickly. Just 1, 2. Okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. Okay, yeah, 10. So that when you divide, okay, 1 plus 10, you're going to get 11. 11. So when you divide by 2, it's going to be what? It's going to be what? 10.5, right? 10.5, and we know that the target value should be in the whole number. So what we'll do, we'll round it down with the floor division so that it can be in that case, it will be what? When you round down, it's going to be at 5, right? It's going to be at 5. So the midpoint now, it will be like 5. It will be at 5 in that case. So we're trying to check, for example, if the midpoint value, okay, like if the target value is greater than the midpoint value, then we need to update now the first index, the left index, because we are not going to use, because we want to stop this iteration and focus on the rest. Let me just add in here pipe. We want to focus now on this other side. So the left value is going to change because it's no longer going to be index 0. So basically, if it's going to shift, in our case, what will be our left value in this list, guys? Which element will it be the first index? Let me see. Because we've stopped like at the first iteration, this first iteration here, because the target value is greater than. So we want to focus on this other side. So yeah, thank you so much. It is 6. So now our first index is going to be 6. It's going to be 6. And we don't need to hard code and specify this value. So we need to write it like with code so that we can specify the midpoint value. Okay, the starting value. So we need to update the left. And we say that Python variables are dynamic. Like when you reassign the new value, you're going to utilize what the new value is, its value. So in this case, we are going to update the left. We are going to update what the left. So left here, we are going to use the midpoint, right? We're going to use the midpoint value and then plus 1. Remember on the floor division, we were trying to round it down to the whole number. So now if you want to get now the second, assuming that this 5 was the first in the midpoint value, then now the left index in the event you are trying to continue on the other iteration, on the other half, then it means that it's going to be the midpoint value plus 1 to get now the other index, the second index. So this how we'll be able to update what the left. And then, so this is, we have updated the left, and you can notice that the right is going to maintain, is going to be constant. So the right is not going to change. But then, assuming that, for example, your target value was here, the target value was 7. Let's assume in this case, the target value was 7. So if it was 7, then we'll have to do what? We'll have to update what? The right? We'll need to update, or maybe let me not go into that. Let me assume that, so this is the midpoint value. In this case, 5. Let's assume this is our midpoint value with our binary search. This 5. When you split into half and do the floor division, let's assume it's 5. And then now the target value is 4, assuming it's 4. So if it's 4, then it means that I will have to do what? I will have to get the midpoint value minus 1 so that we can get like the very nearest index, so that it could be now the last index. Because the essence here, we want to skip the midpoint value, because remember the midpoint value is already going to be caught up here. So for the right, we'll need to update because it's going to now ignore this other side. So the midpoint of this other side and so forth. So now to get this index, you can guess that it's going to be the midpoint minus 1 to get the closest value, right? The closest whole number. So for the right, I'm going to use here okay, let me just use else. I think we only have else remaining. So let me say else, right, we will update the right. So right, so the right is going to be, it's going to be, we say the midpoint, minus, okay, minus what? Minus 1. The midpoint minus 1. And then now, yeah, the midpoint minus 1. So to get now the right. And then after, yeah, so this one, like this how you can now go about the binary search algorithm. And then you could return now, for example, if you have this list, let's assume that this is the list now. Okay, just a second, guys. I take some note. I don't know why my throat is a second. Sorry about that. Yeah, so basically now we could specify, for example, if this is our list, and then for example, if you wanted to call this function, perhaps we could remember when you were calling the function, we talked about that. But then first of all, we'll need to do that. We need to run this one so that it can be in the memory, and then we need to pass in what 2 arguments here. We need to specify the first argument and the second argument. So we need to specify first of all the target value and the sorted list. So in this case, perhaps we could say list to be that one, then above target, we just pass there some target value, Okay, some target value, perhaps let's assume it is whatever number. Let's say it is 30. And then when you call now the function, then you'll be using the same function name. The same function name, then you need to do what? You need to pass in those arguments. So the first parameter, because it's positional, it should be what? The sorted list. And then now the last one, it will be now the target. In this case, okay, actually, okay, do we have 10? Okay, we have, I meant 30. Don't know why I wrote 10. I mean 30 in this case. So all right, so yes, just a second. Yeah, so basically that's how you run it. But then now, okay, first of all, let's run this one and then this one. But then we need to have, I will need to do it. We'll need to specify now the, so we forgot the return statement here. We forgot what the return statement there. The main, assume that in the event, for example, the item is not here. So we'll need to do it. We'll need to specify the our target, it will return, like to return the target, we need to specify how we can return out the target in this case. So we can just say it here, return the return statement for the values in the event, for example, in the event, for example, it's not met, like in this, or in the case of these logics, for example, if it's not at the midpoint, the target value is not at the midpoint. So we need to specify the return statement for the value. So just specify here the return statement, return, then it will be what? It will be the target, right? It will be the target. So, okay, actually we meant the index, right? We meant now the index. So it has returned the value, but then we meant the index. So how can we get the index, guys, on the target value? Because here I've just wrote here the target, but then remember target is just this variable here. The target is just here. So so who can tell us how the trick that we could use to, return the mid, right? No? Yeah, we need to sort this list first. Oh, by the way, we need to sort the list. We need to sort the list. Remember, it works on the sorted list, and that sorted the list. To sort the list, then it will mean that we need to implement the sort algorithm. Guys, I think we could have just used the sorted list already, because it means that I'm going to use the sorted it means that I can use the sorted list, the sorted algorithm, perhaps the sort algorithm to sort the list before I get the output. So this one is not going to work because it works on the sorted list. So another way, for example, is to just manually to had sort this list of hours, and then return the values. Work with it like when it is sorted. But then, guys, I don't want to go into the sorted list algorithm, because it's still part of the quadratic time. Especially when you use the things like the bubble sort, or maybe okay, we have different type of sorts. We have the merge sort, which is part of the linear arithmetic, or maybe the linear time, and the linear time algorithm that we could use to sort the list. But then it means that I'm going to go to that direction, and guys, I don't want to go to that, but I believe you've understood the concept, right? The logic. Should I implement, or you've understood, so that at least I can cover something? Must I implement how I can sort? One way is to just hard sort this one, like arrange the values manually, and then return the values, or use the algorithms. So I think you will be able to manage this one, guys. You can just implement the sort algorithm, or you can do it. You can just arrange your work, sort your work before you use this algorithm. Remember, it works on the sorted algorithm, sorted list. Should I proceed, guys? You'll be able to manage, because I know it's taking my time. You've understood how because this concept here is to understand how these are in the big notation, how it works. So first of all, the binary search, as you understood the logic, it's like trying to, first of all, split the data into half, and then it's trying to check on the target value. If it's greater than, or maybe at the midpoint, or maybe at the less than, and then it's going to split it into halfway. So it's going to use in mathematics, it's going to use the logarithmic time, and then another kind of the big notation. Let me just try to go quickly, because it seems like time is passing. So let me talk about I'll just mention another one. We have the linear time. The linear time is in the event, for example, you want to access this other element using the linear time. For example, when you just have this list, and then let's say you want to access the very last index. So say print, and then you specify, let's say you're interested in the last index. So who can guess or maybe you can give us, for example, the how we can access this last index. Remember, we talked about the len function, how we can use it to get the very last index. Okay, let me just call it last underscore index. Let me not do everything, guys. I want to someone who can give us like the program that I can use to access the last index in this case without counting. Yeah, amazing. Thank you so much. Thank you very much. So you are saying that we could use -1, of which it means that we are trying to get it from the other side, or we could use the len, the len, and then the length of the elements, of which is going to return a scalar value. But then we know that indexing begins from the indexing begins from 0, so it's going to be like at the last index -1, and then I will be able to do it to be able to like now when you try to say when you try to say, for example, let's say we want to print now the very last index in this case, it's going to be okay. Wait a minute. Let me see the program that you gave me. So first of all, we're interested in the element, right? We're interested in the element. So in this case, we are okay. So it should be last. It should be in the list. I should have mentioned, right? I should have mentioned LST because I remember the index in Python, and then I use the index because we don't want the value, not the index, right? Because that is now the last index, and that we need to do it to get the index. So instead of having the one who can tell me the information, okay, I think let me not do this one. I want you guys to give me what I should pass there in the print statement. Let me do this because instead of the index, I want to get the value. What should I write there? I remember we talked about the accessing elements in a list. All right, great. Yeah, so this is the information that we pass here. Because if you do not specify, if you just use this last index, then it's going to return what is going to like return the index and that we're interested in the element. So this one, we're using what we have accessed the very last index. So you notice in this case, the code, okay, or maybe the program, like it's trying to like access this element by going through 1, 2, 3, until it reaches the very last element to return the response. So this is what we call the linear time. Like as the number increases, the time also is going to increase because assuming that you have the element, you want to access the very last element, and in the event, for example, you have 1,000 number of elements. So to access that last element, like it's going to depend on the length, right? As the number increases, then the time to access the very last element is also going to increase. So I've not used the function, but then this is how it should be done. Remember, the key thing here is to understand the concept, or maybe how you should access, and that there are several ways you could do it using the functions, or maybe using as well the class, or maybe directly. But you've understood how the linear time work, the linear arithmetic time work, right? So basically for the linear time, like as the number of the input increases, then it means that to access the very last element, so it's going to depend on the size of the input. So if the number increases, then to access the very last element, it means that it's going to take you a lot of time to access it. So this is on the linear time. And let me just mention the rest. The rest, remember, big O notation is just some mathematical like expression of the algorithm, or maybe a way that the resources that is going to take, and also the time. But then another one we have, we also have the exponential time. So now for the exponential time, like at the time increases, for the exponential time, like the time increases, how can I put it? Exponentially. I don't know, guys, if you understand how exponential, for example, if you have a number like, let's say 10, for example, you want to get what? the exponential. What will be the exponential? Okay, let me use, for example, 3. This is for mathematics. What will be the exponential of this 5? Just some expression, don't even need to write the calculation. The value, given the value. How will I get the exponential of this value? 5, the expression, not even the answer. Like how will I get the exponential of 5? Not, okay, thank you so much for the symbol. But then now, if I were to just write like manually, for example, the exponential of 5, anyone? I don't want to use the algorithm, guys. I want to like assume we're trying to do it like a mathematical way, just manually, like that expression. That I could use, for example, on mathematics. So on um 5 multiplied by 5 multiplied by 2 power 2, right? All right, yeah. So basically, this is for the exponential. Like I trying like an example. We are meant to put like for example, an example, for example, of the exponential case. So like in this case, for example, for the exponential, like that one is trying to like increase the time exponentially. And a good example, let me just mention. I don't want to like explain. A good example is like the Fibonacci sequence. So this one is trying like is a function that it tries to call itself as like it's trying to do the recursive, like it's trying to call itself recursively. Like, normally, for example, when you create a function, you usually like call that function, but then now for recursion, it's like the function tries to call itself. Like instead of calling it in outside, you are trying to implement something that is trying to call itself. And a good example is like a Fibonacci. A Fibonacci sequence is like a sequence that begins from with I think 0, right? 0, and then a 1, 1. Okay, let me say it begins with 1, 1. Then now the next value is the value of 2 subsequent values. So it will be in the next one, in this case, is going to be, for example, 2. Then now to get the very last one, the second one is going to be 1 plus 2, get 3. And the second one is going to be 2 plus 3 to get what? To get 5. Okay, 5, like that. So recursion, or okay, Fibonacci sequence, to achieve it with a function, then you'll be using what? The exponential time. Like it's trying to like do it recursive, because you notice that it's going to go forward then backward. Like the function is trying to call itself, so the time is going to increase exponentially. Power, someone told us like at the power of something, and he demonstrated with 2, and then these 2 could be yeah, so exponentially with the power 2, power 2, like it's trying like to repeat itself, like it's trying to do it like because I'm trying to first of all get what? The latest number, and then I do 2 steps backward, get the values, then I return the response. So you can notice that the process is twice. So the time that is going to take is going to be exponentially. So having that such an algorithm, you'll notice the effect. If you have such a thing, then you know how you need to sort around, because the time is going to increase like exponentially if the data input increases. If the data input increases, when you try to access it, then the time is going to increase exponentially, because you'll notice that as you try to go, it's like like when you try to move, like if you want to get the next element, then you have a function, but then that function is trying to call first of all that function, and then I get the first 2 new value, and then before it go to the next. So the process is twice. It's going to go forward, backward. So it's going to do like something that it could have done once. It's trying to do it twice. So that is exponentially. At the time increases exponentially. And our example I said is the Fibonacci sequence. Research on that. And then we also have another one called um, um, what do we call it? Quadratic time. Quadratic time, that one, like at the time increases quadratically. For example, if you have the nested loops. A nested loop, for example, if you have a good example, for example, if you have a dictionary, then you have another dictionary in it, or maybe if it's a list and then a list inside a list, we talk about arrays. So, and that one is an example of, that one is an example of quadratic time. Like the time it tries to, the time increases quadratically with the input size. So when the input increases, then the time is going to increase quadratically. Yeah, so basically those are the some of the algorithms, or maybe the big O notation, like just some terminologies, especially they usually ask mostly in the during the interviews. For example, you are asked, I have my array list, and I want to access the very first element in my list. What will be the best approach? And you explain with the big O notation. For example, you're asked to explain with the big O notation. Because you'll notice, for example, if you just want to access the very first index, and then I want to go with the binary search. So you'll notice that, for example, if you just want to get the first index, and then you're trying to use the binary search, because it's trying to first of all split it into half, then go to the first one, and then check. Okay, like it's going to check first of all the midpoint. If the value is still at the like it's less than, then it's going to go to the less than side. Then I'm trying to check if it's within that less than thing to try to divide. So you'll notice, for example, if we are using the binary search for a linear time, okay, for a constant time, then it's not going to be effective. Like it will take more time, right? So what will be the best algorithm, or maybe big O notation to use in that case? For example, okay, I think I'm trying to contradict myself, because I mean the constant time. For example, if you want to access the first element, you'll be using the constant, because at the time is going to be similar. The time is going to be similar irrespective of the size of the input. So if you want to use the other ones, the other algorithms, then it's going to take like a lot more time. So it depends on the scenario, on the case. For example, if you want to calculate the very last element, or near the end, then the binary search will be effective, because it will be splitting that into half. So it depends on the kind of problem you're trying to solve. So this big O notation is just some mathematical way to explain this algorithm, how it will perform in the event, for example, of a worst scenario case, like in the event, for example, this very worst scenario. Yeah, I don't know, guys, if you've understood. I think this one I haven't explained well, because I'm trying to rush. I don't know if you guys have understood what I've been trying to say up to this. Have you understood the big O notation, what it does? All right. But then I also have a feeling that I haven't done it well, because I was in a rush. So guys, let me quickly talk about the classes. I think it's very important. Let me talk about the class, and then I will be done with the Python classes and object. So basically, class is like a blueprint for creating the object. First of all, I said that almost everything in Python is an object. So for example, if you have something like a list, now remember there's an inbuilt function called list. So I don't want to use okay, let me just say how can I put it? Let me just say lst, and then I have this list of item, for example, 1, 2, 3, and then I want to get the output using the type. To get the type of the elements or values there, I'll use the type function, and then you'll notice the output is going to be it's going to say list, and then it's going to say class something, and then the value. You can notice it was just a regular list, but then Python is treating it as an object. So like nearly everything in Python is considered as an object. That's why it's that's why Python is object oriented. But then now to learn classes and objects is a very, very important thing in Python, because you notice almost everything is like an object. Like consider a scenario, for example, if you have the forest. The forest, let's say you want to discuss or maybe understand, you want to do some research about, for example, the species in a particular forest. So perhaps you could have like a class you could have a class, for example, you could call it trees, or maybe you call it forest. And then under that class, you could have, for example, under that class, you could have, for example, algorithms to for working with the different type of species in that forest. But let's use a different example. Let's say we have cars. Cars is like the general thing, like an umbrella, but then under it we have different type of models, or maybe car brands. I think brands within that the cars. So a class like something big, which is defined with the class keyword, and then at the class name, which you can use the okay. By the way, guys, let me ask you, which naming convention have I used in this one, in this class? I talked about it the other time. Have you, and do you recall the naming convention that I've used here? Yeah, Pascal case naming convention here. So basically a class is created this way. And I want to begin simple. Let's try to create something on this class, just a simple thing, like a x, we assign it to 10. So basically, if I want to get this value, when in Python function normally you could have just called the function and then I get the output. But then now in this case, you have to first of all create an instance of this class before you create this object, or maybe call this object. So basically, for example, to create an instance, I said that a class is like a blueprint, or maybe the constructor for objects, something that you use to create the objects. So in this case, to create an object, you'll have to do at least use a variable to create an object. For example, let's call it class, okay, object one, object underscore one. And then in this object, now to create an object out of a class, you are going to just use the same class like that, but then it ends with the parentheses. Now this one, it doesn't have any properties, so we are just passing like an empty the way it is. So, for example, if I want to print, for example, this obj underscore one, like I'm going to get some random numbers here, of which it's not auto intended. Perhaps we could have wanted, for example, to get this value, this 10, okay, this variable here. So you can see it's not just returning directly. So we need to do it within that object that we've created. Now we need to do it. We need now to call them, or maybe target whatever property that you are trying to look. For example, in this case, for example, if it is for example, if I wanted to get 10, then I'll say, for example, the object that we've created, then I pass here my variable so that I'll be able to get 10. Now let's try to put it this way. An object, let's go call ourselves objects. So let me be an object, and you are also an object. Now, you need to do it. You will, like, you have features like the hands, legs, head, and all that. So those are the features. Now, for example, I will need to, first of all, I need to have something to just reference you. And then perhaps I could use, for example, a name just to represent like the whole of me, to represent me personally. Although I have other features, but then I've just used a name just to recall, like to how can I put it? Like I've just used my name to represent the whole of me, the whole of me. But then, for example, if I want to access, for example, to know, for example, my how can I put it? Like the clothes that I've worn. Is it? How can I put it? I don't know how things are very, how can I put it? Like, for example, let's say I've used, for example, name to represent me. Now, if I want to get more information or an information about me, then I'll use, for example, that name. Then, for example, I'll say Nehemiah is wearing a particular kind of hoodie or a particular kind of trouser. So we are using that object, the name, to represent what the object of which is me. And then now within that object that I've used name to represent, then I can get more information about that object. So you can now consider like objects, like we are trying to like within the people class, assuming that I'm a person. So I'm using now the person as an object. But then now from the person object, I'm trying to get someone. For example, Nehemiah. Nehemiah just to represent the personality of Nehemiah, or maybe Kevin, name Kevin to represent the personality of Kevin, although they have other features. So like something like this. For example, let me just try to demonstrate with the person class. Let me say class, then I'm going to use person. Let me just use person. A person could have what? How many features, right? Could have many features. And above, let me just say name. And then above, let me add it here, for example, Nehemiah. So this is so these are just a class. Then within that class, I've just created what a variable Nehemiah. So for me to be able to get this feature of parts of from this class, I need to first of all construct an object. I need to create a person, okay, an object. Perhaps let me call it person one, P, or just let me use P. And then I need to instantiate or maybe create an instance. I say that classes are the blueprint or maybe the constructor for objects. So if you want to create an object, you're going to use what is the class. In this case, it doesn't have any property, so we are just using the empty parentheses like that. So this way, we have done what we've created the object. Now, if you want to get like now information about the feature, okay, when you print the P, you'll notice that it's going to give you some values, some random numbers, just to represent the object. Like I've created here an object, and then it has given out some output. Like Python is trying to figure out the name that it could give to this object. For example, if you just see people there, I just see people there. For you to identify someone, you'll need something that that's unique to identify. For example, a person wearing a particular color of clothes, or maybe who is tall, who is short. So like you need just to have that thing that you're going to use to reference. For example, you could use, for example, the name, or maybe the dressing code, or maybe the height of a person and all that. But then now Python is trying to figure out what name it could give this object. That's why we are getting this random information. But then within this object, now we're able to get more information. For example, about the object, we could say, for example,
Zoom.
yes, yes.
Kò tá mi. Mi kàn fẹ́ kí orú bẹ̀rẹ̀ sí ní máa mú mi kó sí kí n tó mú mi fẹ́.
And then I could add in here, for example, if I want to get now more information, for example, name, I'll just pass here a name.
Èmi dẹ̀
I'll
mo
just
bẹ̀rẹ̀
pass
kọ́
here
yẹn
a name.
mo kọ́ yẹn kò ní stop. Technology.
Hello,
lórí Twitter ó ti lọ.
Ó sì lọ.
Ìgbà míì dẹ̀kẹ̀rẹ̀ kò ń lọ lórí Twitter.
who is talking?
Ìjì rí bẹ́ẹ̀.
All right, so yeah, so basically like this is a basic way on how you can create it, but then we know that we need to have more properties about a person. Let's try to create like make it have more properties or more features about a person. So like if you want to create like a more properties, or if you want to create like a properties for a particular object, or maybe a particular class, then Python has an inbuilt function called init function. So we have the class, let's call it person. But then now if you want to create like a more properties about the person, remember on the properties, you want to like utilize something that is common among the person class, or maybe the person, like for example, the person who, for people, they have what things like names, or they have the age, or maybe like you just want to have like things that are very unique on all like these names. So you'll be using them as a variable. Remember the essence of class is like to categorize related thing, like something that shares the common thing. You want to group them together. Together so that you can create instances of the same thing. For example, you have the same person that has name and age, but then now object will differ. For example, another person perhaps has a different name and a different age, but then it's utilizing what the age as a feature, or maybe as a property, but then you can create instances with different more information. So if you want to create like those common information or properties, then I use what the init function. So I could use here div, but then this is an inbuilt, so you cannot use it as your normal function, because there's an inbuilt function that you have to use it in it. And then now to show that this properties belongs to this class, the first parameter that you pass here is just an associating parameter. For example, when you use self, this is not an argument. Remember, in function, we say that, for example, especially when you're working on the positional arguments, you need to do it, you need to give it a value. Otherwise, when you don't give it a value, you'll get an error. But then in the class case, and in this init, so this first parameter here is just to show that we are associating this with this person class. Then the rest is the information that I could add in to this person. For example, we could use things like a name, and then age. These are the properties. These are the properties. Or perhaps I could use something that, okay, I think let's try to use things like height, right? Let's use a height. What else could we use as a feature for person? What else can we use as a feature for a person? Yeah, weight. Let's use height and the weight. Okay, yeah, height and weight. Height and weight. Height and weight, these are the features for a person. And then it's a function, so you need to end in with the colon. So these are the features, this is like properties. Now we need to do what we need to like assign variable, create variables for these features, for these height and the property. Like these are not like considered as properties, not like our normal how can I put it? Like these are just like properties. We need to now create variables for them so that we can utilize them within this class. So to create now the variables for this, we'll have to use first of all self. Remember this self parameter that we are using here is the one that we are using. Remember, it could be any other name. But then remember that the first argument that we are passing here, or a parameter, is just to show that you are associating this function with a person class, with a class, specified class name. So here it's self, and then I specify the property, for example, height. And then you can give it a variable. Let's just use height, the same variable. And then now for weight, we still use the self. And because there is something to associate with the person class, then I will say specify the property. Remember, it could be different name for variables, but then to put it into context, we're just using the same name. So we're using here weight, and then I'm assigning it to weight. I'm not sure if this is the spelling, but then let me just say weight. Let me say weight. So these are the properties for this person, and these are the these are the properties. But then we have used what we've used this self to make it like a variable, to make it like work as variable, such that when we'll be calling or creating the instances, we'll make sure that each instance utilize this feature. So so we have done what we have created this person class. And then we have added some properties for this person, like a height and weight. Now to create an instance, let's call it person one. Perhaps, okay, let me just say person one. So person one, okay, let me just say person_1. So for the person one, we say that we need to use the class as our constructor, object constructor. So our object or person one, we are going to use this class. But then you notice that now we have properties for this person. It's not empty like previously. It's not empty. Here we've done what we've added the properties using the init. Remember, the init is an inbuilt function that you need to utilize whenever you're trying to create or maybe assign properties to a class. So in this case, we need to do what we need to give values for this height. A height of a person can be how many? 6 feet, right? 6 is long, I think. Is it 5? Let me use a number. What is the moderate or average height of a person in feet? Yeah, 5.5. Yeah, let's use 5.5. And then the weight, this one will vary, right? Depending also on the other factors. But then we can use what? Let's use 60. Yeah, let's use 60. 60. 60. Remember, there are some things that will not say that this is an average. You know, it depends also with the height of a person. You know, for example, if you are 10 feet, and then your weight is 60 or a 50, then that is not going to be, that's not going to it's not going to be how can I put it? Like also there are some other factors that I could lead to the weight for average. So this one you cannot use average, but then let's just use 60 for the demo. Okay, for this case. So we've done what we've created now a first instance or an object for person. Then we're passing the height and the weight is its property or a feature. But then remember this self is just something to associate the person or maybe this property with this class. So you don't pass it as an argument. Remember on the positional argument, we said that the number of arguments that you passed here or parameters should have the same number of values that are when you'd be calling, when we are talking about the functions. Now, here when I do the print, and then I pass here this object, I still get some random numbers, but then now I can do it, I can be able to access more information from this person. Perhaps because we created the variables here, we can pass, for example, the height, and then from that person, we're able to get what the height of that person. So we created the person. So if you don't include self, then it means that it's not part of this. First of all, this init is like as an inbuilt function for working with the classes. So you have to utilize this one. Then this self is just associate it with the person. If you do not use it, then it's not a method. Remember, we have the difference between function and a methods. Function, these are normal function that you define it in a new line, but then our methods, these are functions that you define inside the class block. So you can notice that we have the indentation here. You have the indentation here, and then for the methods, we are beginning with the self. We are beginning with the self, just self to show that you are utilizing or inheriting, or maybe you are associating it with the class. So this one is just something to associate. It could be self or any other name, but then the other name that we'll be using, make sure that it will be the one that we'll be using consistently. So there's just a parameter to associate your method with the class. So if you do not use it, then it means that it's not a method. You'll get a syntax error, like I get the error. Don't know if it's clear. Yeah. Now, so we're able to do what we're able to get what it is output here. But then guys, you notice that if you do not specify something to represent our object, okay, I think let me just utilize the same thing. If you do not do it, if you do not specify something to associate your object with, when you try to call, I don't know why I created something new. I should have used the same thing. So if you do not specify what to represent your object, then Python is going to struggle to know what name to give your object. So it's going to give you like some random number here. But then if you don't want these scenarios, this case, you can Python provides the string, like a function that you can use it to have a string representation of your object. So instead of having this whatever, you could have something to represent your object. Could be, for example, then in this case, can we add in also here? I think let's try to add in also name, right? Let's try to add in name. But then you notice that because it is positional, when we have 3 arguments, so when I run here, I'm going to get here an error because it was expecting 2, but then 1 more was added. So it's positional. Positional begin from here, from the height, from after this first parameter. So I'll need to specify, for example, the name in this case. Let me use, I don't want to use Nehemiah this time. Let me use James. Don't know if we have James in the call. But then, so we have this, the height, weight, in the name. So we need to have something to reference a person, right? Instead of having this object, we just need something to represent. Like, for example, when you say, I am Nehemiah, I've just used the name Nehemiah to represent the personality of Nehemiah. It's just something to represent the person. Another person would reference me with the color. For example, could say, for example, that black person. Still, they are referencing not the personality of Nehemiah. So they are objects, but then we just need to have something to represent the object. So Python provides a function that I could use it to. It's an inbuilt function as well in Python called str. So we are creating now, remember it is in line with this first div. Make sure that it is in line, otherwise you'll get the error. It should be within this indentation block, like whenever you're trying to create the methods. Methods, remember I'm calling it methods because it is utilizing what? It is under the class. So, and then I'm going to say here 2 underscore, and then str, and then underscore. Then I pass here, okay, 2 parentheses. But then now to show, we said that if I want to associate it with the class, what will we pass here to show that there is a method for this class? What argument or a parameter should I pass there? Their self. I need to pass their self to show that it is a method for this person class. And then we could have something to represent the object. So let's use return, and then we could have formatted string or any other. Okay, let's use not formatted string. Let me just use a variable here for the weight. You can guess the how I could use, for example, if I want to get the name. Actually, let's use name. I forgot to add in the name as well here. Let me add in the name. So, for example, if I wanted to get the variable name, who can guess what I should write here? If I want to get the name, yeah, self name. First of all, you must begin with the self. You have to begin with the self to show that you're inheriting the properties from these properties from this person class. Otherwise, you'll have another scenario where you could have wanted to add in like other features. For example, there are some people perhaps you're interested perhaps in your general categorization or maybe properties for a person. You only have the height, the weight, but then you wanted to create also another method that I could utilize, for example, things like the nationality of the person. So you don't want to group it, perhaps it won't be utilized on all cases. So you want, for example, to create a custom for individual class. So we're going to talk about that one in a few, but then in this scenario, we're using first of all self and then name, self.name, self.name just to utilize like the properties from this person class, which we define with the init function. So in this case, now when I run and then specify, okay, run this one again. Now you can see instead of getting those kind of thing, long name, I'm getting now these James. Remember, James is a name. We are not meaning that the person object is James, but then we've used what James to reference what our object. Something just to associate you. For example, if you want to know the president of Kenya, what name will you say if you want to reference the president of Kenya? Okay, don't mention, don't type. But then, like you have the names that I could, like when you call it, is going to like refer to someone. But then it's just something to refer. Perhaps you could use, for example, a nickname to refer to me, or I could use, for example, the color, or maybe the weight. Okay, I think that's weight to reference me. Like this is just something to reference. It's not like the personality, like a person have many features, like for example, the nose and all those. But then in this case, we are just using something to represent the personality of this object, the object name. Perhaps another person could use height. So when you use height, then the object is going to be height, like the output is going to be height, but it does not mean that it represents what? Why am I getting this? Oh, sorry. um, where? Let me see. All right, remember this is string representation of objects. So the numbers, these are numbers. They are not string. If you wanted to use like those, if you wanted to use like the height, because it's not it's not a string. Who can guess what we'll do to make sure that it returns, for example, the height? Because it wants strings. On the string representation, you need to utilize the string. But then we try to use yeah. So this one we are trying to hard code, okay, to make it a string with the quotes. But then another way is to format, right? Just to format the string, so that it will allow us to utilize what the variables inside there. inside the string. So it is still going to be the string, but then now the output is going to be this way. We've just utilized the string, but then now we've used that number inside what this quote. This curly braces so that we can utilize the variables inside the string. So someone could utilize, for example, someone when they just say 5.5, they will know that they are referencing a particular person, or perhaps when they say, for example, 10 feet, people will automatically be able to identify that person. Like we are just using it to identify something. I don't know if up to there you've understood, guys. Up to there. Yeah, great. Now let me proceed. Let me use let's talk about the methods. Let me talk about the methods. And I don't want to utilize this thing because I don't want to make it long. I want to utilize simple things to explain. Now let me just create now my manual or maybe my custom method. Method, I said, is a function that you're trying to use inside what? A class. Perhaps, and I will say that function are defined with the def keyword. Then perhaps let's use it greeting. Let's create a function called greetings. Now to associate this, or maybe to make this function a method, we'll need to do what? We'll need to pass yourself to associate it with this person class. But then we want to utilize what these features from this person object. So here we could do what? We could create something here. Perhaps let's say return, and then in this return, perhaps let me use a formatted string so that I can create some nice string. For example, hello, hello, I am, I am, I am, and and yes, okay, kilograms, height should be feet, right? Feet, and then feet, and what? I weigh. I'm trying to construct here in English, guys. I'm not good at it, so just bear with me. And I weigh. I think it should be weigh, right? To measure. I weigh. Then I'll pass here some value. So who can tell me, for example, the information that I'll pass here, for example, to get the name? If you still remember, someone gave us the hint earlier. For example, I wanted to get that part of the name. Yeah, self name, self name, self dot name, and then here for feet. For feet, basically it's height. I think height here. So height, another person. Yeah, another person. Yeah, self dot height. Self dot height, and then last person for the weight. Yeah, weight. Thank you. Self dot weight. So you have to use the self. Don't forget, otherwise it will be your normal function and it's not going to work on a class. So self dot weight. So this now a method. This now a method. There's something that I'm going to come and explain in a few. For example, if you wanted to like have like a default arguments or maybe some your random argument that you could utilize here. So yeah, so we've constructed what we have created here a method, and then we are calling it a method because it is utilizing the property from the person class. It is within the person class or maybe your class. Now, when you run, nothing is going to happen. And if you want to get these greetings, so can give us the hint. Now we can be able to get this output. How can we be able to call this function, this method? Remember, they are similar to functions, but then we are calling them methods. Who can tell us? Will I have to first of all construct the object? Yeah, I'll have to first. Yeah, thank you so much. I think there's person who said person class. Then greetings was in the right direction. But then now remember, you need to first of all instantiate. You need to first of all create an instance of the person. So all of you guys, you are right. Only that whenever you're using methods like for example, if you want to call a method, you need to it should be after an object. It should be after an object. You remember, for example, when we are saying, for example, let's assign here to a name. I don't know why I use my name most of the time. For example, if I want to make it an uppercase, then for example, let's say print, and then I use the object. Remember, it's considered as an object in this case. Like we say that in Python, almost everything is considered as an object. So we are first of all beginning with the object and then the method. So we have the inbuilt methods in function that I can use it, for example, to make it an uppercase. So it doesn't take any argument. So upper is going to automatically give us the upper. So remember, methods come always after an object. So I think this should be the main difference, right, between the functions and the methods. So the methods comes after comes after your object. And your normal function, you could call it directly without any object, associating it with the object. So this day, I think the main difference, like an object, okay, methods comes, if you want to call them, like you have to call it after the object. Like in this case, it's our object is x, a variable with variable x to represent it. We said that almost everything in Python is considered in an object. Okay, so because now we've created here an object, okay, class, we need to do what we need to create an object first before we call the method, right? So we need to, first of all, let's call it P1 to represent the person. And then let's instantiate the class, or maybe create an instance of this class. When you create an instance, we say that our classes are like the object constructor. The object constructor. So if you want to create an object, you have to utilize the class. You have to call or maybe instantiate the class, create an instance of the class. And then, because we have arguments here, when we try to use without, we'll get what the error. So we need to pass in this information. Okay, let me just utilize this. It is positional. Remember, things that we talked about on functions, they are similar that like you could use the same here. The arbitrary arguments, normal arguments like what we're using, these positional arguments, or keyword arguments, arbitrary keyword arguments. Still, you can utilize the same information here. But then now just for, in this case, I'm trying to just explain how to work with the classes, so I'll not have to go into that. If you want to learn more about those, then you will reference the class for functions, because I explained it, I think. Now, I'm done what I've created an instance of this object, of this class. So it's now object P1. Now, if I want to create now this, to call this function, I'll have now to say print. And then I'm going to specify an object, because we have done what we have created our object, our custom object manually. So you need to specify, for example, in this case, it's P1, the object. Then we specify the method, right? We need to specify the method, which is greeting, and it doesn't take any argument. Remember, this self is not an argument for greeting. Like I just use it to associate it with the class. So in this case, now we are able to get the output. Guys, have you understood, or should I repeat? Let me repeat. So first of all, we've created what? The method here. First of all, we created these properties for the person class. Then we also created what? The methods. And we realized that we could not pass directly this, or maybe we could not call these greetings directly as our normal function, because it is part of this class, like as a feature or something within this class. So if I want to call it, you need to first of all create an object. And we demonstrated earlier with an example of text, and then we assign it to a value like a 10. And then when we try to say it, print, then type, for example, x, Python is going to consider this one as an object. When you're trying to run, you can see it's going to consider it as a class. Basically, remember, class, these are object constructor. So remember, it's just referencing the object class, because it's an object constructor. In this case, we have tried to demonstrate how we could create an object out of a class. So whenever you say class, remember this, it is an object, right? Now, when you use a string here, for example, okay, let me not use let me say Mary. Let me use Mary. Mary, mother of God. So the object is str. Okay, like I can see the output is str. Now we have the inbuilt methods, the inbuilt methods. Now we're able to do it. We're able to utilize those methods by specifying, because this one is like an object, right? We said that a method can only come after a method, right? You have to have a method before you have to have an object. I don't know, guys. I think now I'm confusing you. This X that we've created here, Python automatically is going to consider it as an object. We have demonstrated this one here. It's going to be considered as an object. And if I want to utilize a method, we say that this is a function defined within a class. So if I want to utilize like a function within the inbuilt functions or maybe inbuilt methods in Python, then you need to first of all specify an object, because we understood that methods can only work and it comes after the method, they go hand in hand with the object. Like you need to have first of all the object, then you call the method. Otherwise, it's not going to, you get the syntax error. So in this case, because we have understood that this one is an object, this X, so we are going to pass in what here, an object that we have just created here. And then, in Python, we have an inbuilt method called upper, as we demonstrated earlier, which converts it to the uppercase or lower, sorry, the number of too many, or lower to lower it. So you notice that these methods are coming after what? Your object, right? So anytime you want to utilize the methods, you have to have the object somewhere. So just remember that whenever you want to call the method, you have to associate it with, you need to first of all create an instance or maybe an object before you call the method. You call the method, and to create the object, you first of all specify you can create a variable, or you could just, it's a good practice, guys, to create a variable, a descriptive name, by the way, and then you give it you instantiate the class with all this information. If it were, you had added the properties, and then when you call it, so it's going to utilize these properties as your default values, and then now when you call it, you'll be able now to call this object that we've created here. And then the extension now is the method, like from the object that you have instantiated or created. Then now within that object, you could utilize like the feature. Like in other words, let's try to put it this way. Like you can see in this class, we have added many things. We have added many things. We have this INIT, we have the greetings, perhaps you could add in many other methods as well. So when you create an instance, it's like you're trying to create a version of this person class with all this information, but then you'll be interested perhaps with some specific features from that class. And in this case, we have created like this person of which is going to have all this information. This person that we have created here is going to utilize all this information, but then within all this information, perhaps you could be interested only with the greetings, or perhaps you're interested on a variable name, things like that. Then it's going to return part of those features. So when you create an object, you're trying to create an instance of this entire class, with all the features here, so that when you try to call it, you'll have first of all to specify the class, and then within one of the feature within that class, so that you can get the output. So this could be, for example, person one, you could create a main instances, for example, P2. So this is another instance of the class, but then with different information, perhaps could be 6, and then for example, whatever, 8, 4. Okay, let's assume it's a child 3, or even there are some big people who are very short. So yeah, so these are the information. So you can see now when I run 2 and then 3. Sorry. I'm getting this error that P2 is not defined. Oh, okay. First of all, you need to run. Remember, guys, for notebook, you have to always run so that you can be in the memory. If you see something that is yellow, just know orange. I think this color is orange. I'm not sure, not good with colors. You have to run it that way so that it can be active. Then now when you run, now you can see it is still the same, like we have created what different instances of this person class. Now you can see the information are different. Information are now different. So we have created like a different instances of this person class. Let me know, guys, if you've understood these things. All right, great. Now, I think last thing before we wind down, sometimes let's say you want to create like your custom function, okay, your custom arguments or parameters. For example, in this greetings, you could also want to have age. So you are going to add here age. But then, so in this age, because you've used it manually, like how can I put it? Like you've used it um, like manually, if I like in lack of words, let me just call it manually. Let's say manually. When I pass like this parameter here directly, I think that's the correct term, directly, without using the self. Okay, I've used first of all to show that it's a method. You need to utilize the self, but then on top of that, I've added like at the age variable directly. Like it's not part of this uh, um, uh, class properties, but then I wanted like this greeting to only have an extension of this thing, for example, the age. So basically in this case, for example, if I want to utilize it, I'll have to do it. You can guess, for example, my age is, who can tell me, for example, which variable should I utilize here in case I want to get the age? Yeah, I'll just pass. Yeah, just pass. So in this case, I'll just pass here age. Remember, when you self, it means that you are referencing what? This property for the person properties. Whenever you use the self, it means that you want to inherit all these properties. But then because in this one, we are only interested in this age. So we are passing what? The age directly here. We are passing the age directly here. But then now, because we've passed here the age, when I run here, I'm going to get the error. I should get the error. Okay, so let me try. Okay, I see that anytime you say it is yellow, gray, orange, I'm the one that I'm telling you, but I'm the one who is forgetting. So whenever it's yellow, just know that it's not active, like you have not run it. So now when I run this method, I'm going to get the error because one positional argument is required here. So for example, in the function call, because the edges should be a number. So I need to, on the function call, I'll just pass here my arguments here. My custom, for example, arguments 25. So this is in the event for example, guys, you want to extend like your custom methods. Perhaps let's say you could let's assume it is car brands. It's a car brand. Okay, let's use, for example, let's assume that it is arithmetic function that, okay, arithmetic class that you want to have. You could call your class, for example, things to do with arithmetic. And then under it, you could have, for example, addition. You could have addition. You could have multiplication, division and others. Those kind of arithmetic operation, which utilize like numbers directly. For example, number A and number B. To do, for example, the addition or subtraction, you need to have those two numbers. But then it reaches a point that you have something that you want to get, for example, the maximum number. You want to get the maximum number. So it means that you're going to need to have, you need to have, for example, something like a list, right? Something like a list so that you can get, for example, the maximum number. So on that list, you could have, for example, you could inherit, for example, the features for A and B. But then in addition to that, you could create what a custom list where you'll be able to get what the maximum number. So like the properties that I usually use in the init, like these are the things that all the other things should utilize or maybe it's a common denominator for everything. For everything is a common, like for example, if you want to know a car, like all cars will have for example, 4 tires, it has the colors and all those things. So these are the key things that you notice, like if you want to identify what is a car. So these are the key things that is going to cut across all the cars. But then within those cars, perhaps we could have like things which are unique from one car to the other. But then, for example, things like, for example, the number of tires, the number of the color like could be same. Okay, like the color, depending because they are variables. They are variables. You could pass arguments there, for example, different colors. But then you will be sure that all the cars have colors. I don't know if there's a car which is colorless. So these are key things that applies across all the cars. But then you could have, for example, things like brand, color, and what else? Color and the year of the year of production or things like that. So those are the key things that I want to include. But then you come across, there's also another car and that has something that's very, very unique. It's not common like those features, like in addition to all those common features, it has also an additional feature. So in that case, you could add it here manually so that it will not affect the other instances or maybe other cars that do not utilize that feature. So you could have that directly here. Like I'm just using that one to demonstrate where you could utilize your custom variables, okay, your custom parameters on your methods. I don't know, guys, if that makes sense. Have you understood that? Have you understood? Okay. Yeah, so guys, basically there are many things that I could teach you. For those who will be taking this program after the onboarding, we'll talk more details about the classes, including the properties like the inheritance, polymorphism, nature of Python, Python classes, and all that. Like there are many things that we haven't talked about because when you try to do it, you can notice that it's already 6. It's already 6, and we cannot manage to cover all those things. But then for those who will be taking the programs, like I will try to advance, but then in a nutshell, this is how the classes work. So far, I believe you've understood how to deal with the variables. We began with it. There are structures, functions, and because Python is an object-oriented language, we've talked about the classes and objects, how to be able to construct objects out of a class, and also methods and many other things that we've talked about, the string representation of objects and all this. So guys, let me know if you've understood something on Python, or maybe if you've learned something on Python, or maybe if you have a question perhaps as well. Let me know before we hand it over. And I remember now from tomorrow, I'll talk about the packages for machine learning, just to mention the packages that we'll be using in the machine learning and artificial intelligence. And then the other day, now we talk about the Git and GitHub. Like all developers must know how to work with the Git, those basic Git commands, how to create the issues, how to collaborate, how to do the pull requests, and many other things. Yeah, so those are the things that I will talk about when we reach to Git and GitHub. Then after that, perhaps if the days will not be over, we'll talk about now. We'll just have the revision. Remember, for the mini projects, I actually wanted to have some mini project, but then you notice that when I'm in a hurry, I struggle to explain things or a concept, and it's not even ideal. So we might have another day where we could just do some mini projects, how we can create like a simple calculators and those small things, and so that you understand how to utilize or maybe put into utility these skills that you've acquired. For example, the variable skill, the structure skill, function skill, classes skills, the conditional statements, the while loops, to be able to do it to achieve something great. So I think if time will allow, we'll have that session, and then I think it will have come after. It will have come after the Git and GitHub. So we'll be able now to do the code challenges. We'll be using it on the GitHub Classroom. So you'll be submitting through the GitHub to make sure that you guys understand how to work with the Git and GitHub. So those are the things that I guess I will be talking about. Guys, I think this should be the end of Python. I think Python is big, but then now for me to teach you or maybe to give the beginners the foundation, I think this should be the end. Let me know, guys, if there's a question or maybe any comment before I hand it over to one Dev or Aisha.
Thank you very much, Mr. Nehemiah. I didn't want to interrupt you. Our time has finished since, but I was like, let me not interrupt you. The class is getting intense. I can see that the participants are responding really well. So I was like, let me allow you. Thank you guys for staying till the end. Today is the end of day 7 of our class. We have 3 days left, which is tomorrow, Friday, next tomorrow, Saturday, and on Monday, right? So, yeah. Again, I want to remind you of the assignment. I already dropped the link in the group for people that are yet to like see the link. Submit your assignment there. Also, I will share a spreadsheet in the community so that you can enter your name, your email, and your phone number for certificate collection after this boot camp. Also, please make sure you do your assignment because we'll be considering assignment for certification. Yeah. So yeah, I don't want to keep everybody waiting for too long. Thank you guys for joining in. We'll see you again tomorrow, the same time. Um, the same time, the same link, right? So yeah. Also I would be asking you to give me feedback in the community. Please make sure to drop your feedback. I would also share the recordings in the community so we can have access to it. Yeah, so see you tomorrow, guys. Have a wonderful rest of the days. Bye everyone.